What does it really mean for an AI to think? Today, we're diving deep into multi-agent companies, frontier LLMs, tool use infrastructure, and agent communication protocols now enable entire companies to be structured as multi-agent systems. This is coordination automation, not merely automating tasks, but the decision-making and handoff logic between them. Agent-native organizations are executing cross-functional projects at 10x the velocity of traditional companies, creating asymmetric speed advantages. The shift redefines organizational design from static hierarchies to dynamic, self-assembling agent networks that learn and adapt. What the slide communicates: the emergence and strategic imperative of multi-agent companies as a new organizational model. But here's where it gets interesting. The coordination ceiling. Human-centric organizations hit a hard ceiling, managerial bandwidth limits throughput as complexity grows. Linear automation RPA, single AI copilots, static pipelines only optimizes individual nodes. The coordination layer remains human bottlenecked. As AI capabilities commoditize, the critical constraint shifts from intelligence to orchestration. The result: powerful models idle, waiting for human handoffs, approvals, and context transfers, wasting compute and time. This systemic underutilization demands a new architectural approach to organizational coordination. What the slide communicates: the core bottleneck: existing models can't scale coordination, making single-node automation insufficient. So what's the real problem? Let's talk about single-agent fragility. Monolithic agent architectures are brittle. A single reasoning error cascades through the entire task chain without correction. They lack specialization. A generalist cannot match deep domain expertise across legal, engineering, and finance simultaneously. No collective deliberation. Alternatives aren't explored in parallel. Errors go unchallenged. Scaling them requires exponentially larger models, hitting diminishing returns, and escalating costs. The root cause is treating intelligence as a centralized function, not a distributed system with checks and balances. What the slide communicates: the architectural flaws of single-agent systems that make them unscalable and unreliable. This raises a critical question: agent-native architecture. Breakthrough multi-agent systems distribute cognition across specialized agents that communicate through structured protocols. Each agent owns a narrow domain: legal, engineering, finance, with deep tool integration and domain-specific prompting. A shared persistent memory fabric enables cumulative learning across the collective. Dynamic role assignment and inter-agent negotiation replace rigid sequential pipelines. Key properties: composability, mix and match agents, resilience, failure isolation, and self-improvement, collective feedback loops. This architecture transforms organizations from machines into ecosystems. What the slide communicates: the paradigm shift from monolithic agents to collaborative, specialized multi-agent systems. Now let's zoom in on multi-agent operating system, MAOS. The MAO stack, task decomposition engine, translates strategic intents into directed acyclic graphs of subtasks with dependencies. Agent registry, catalog of roles, capabilities, SLA profiles, and cost parameters. Coordination mesh, event-driven bus supporting handshakes, auctions, consensus, and escalation protocols. Shared context store, vector databases, knowledge graphs, and episodic memory for persistent state. Observability and governance, real-time tracing of agent decisions, resource consumption, and compliance checks. This layered architecture provides the substrate for an agent-native enterprise. What the slide communicates: the system blueprint: a modular operating system that powers multi-agent companies. Here's something most people overlook: core primitives. Agents, bounded roles with clear authority, fallback policies, and identity. Tools, standardized interfaces, APIs, browsers, code executors, databases wrapped as callable functions. Protocols, interaction patterns, request racksants, broadcast blush bid, peer review, delegation escalation, artifacts, versioned outputs with provenance tracking for auditability, evaluation, automated quality metrics, human-in-the-loop overrides, recursive critique loops, security, per agent identity, permissions, sandboxing, and content filters. These primitives enable reliable, secure, and scalable agent collaboration. What the slide communicates: the foundational building blocks that make multi-agent coordination programmable. Think about this for a second. Adaptive execution loop. Intent-captured planner agent decomposes into a directed acyclic graph of subtasks. Dispatcher broadcasts tasks. Worker agents claim based on capability match and current load via market, mechanism, or direct assignment. Multiple parallel work streams produce candidate outputs concurrently. Assembler merges results. Reviewer agent evaluates quality and goal alignment. Failures or low confidence trigger replanning, human escalation, or agent fine-tuning. Each loop updates shared memory, continuously sharpening the system's performance. This replaces static project management with continuous adaptive execution. What the slide communicates: the dynamic workflow that eliminates linear, human-dependent project pipelines. And this is where things get complex, from hierarchies to internal markets. Traditional organizations statically allocate tasks. Multi-agent companies implement continuous internal markets. Agents bid for incoming tasks based on capability, current load, and projected quality. Pricing signals latency, cost, accuracy, dynamically balance workloads, and prevent bottlenecks. This eliminates managerial approval queues and static role constraints. The organization self-assembles around goals, fluidly reallocating resources as priorities shift. Result: a market-based coordination model that scales without adding overhead, adapting in real time. What the slide communicates: how market mechanisms replace org charts, enabling fluid, scalable task allocation. But here's where it gets interesting: economic speed. Multi-agent companies compress project life cycles from weeks to minutes. They scale horizontally by adding specialized agents, not managers. Collective learning yields compounding returns. Each task enriches shared memory, accelerating future work. Error correction becomes systemic. A misstep by one agent teaches the whole swarm. Early examples: software shipped with zero human code, legal contracts drafted in seconds, financial analyses completed autonomously. This is a step change in organizational velocity, with coordination costs trending towards zero. What the slide communicates: the measurable impact on speed, cost, and scale, a new operational economics. So what's the real problem? Let's talk about the self-designing enterprise. Agents continuously monitor performance and propose structural optimizations, workflow redesign, role adjustments, tool upgrades. Bottlenecks are automatically detected and resolved by rerouting tasks or spawning new agent types. The enterprise evolves its own architecture, self-healing when failures occur, self-scaling under load, self-optimizing for cost. Human oversight remains essential for setting strategic intent, ethical boundaries, and handling extraordinary exceptions. The company transitions from a static machine to a living, learning system that improves with each cycle. What the slide communicates: the future state enterprises that autonomously reconfigure and optimize themselves. This raises a critical question: Emergent organizational intelligence. Multi-agent systems exhibit swarm intelligence. Complex, novel solutions emerge from simple local interactions and protocols. Collective memory becomes a proprietary strategic asset, outlearning any individual expert. Organizational knowledge shifts from tacit and fragmented to computable, queryable, and instantly actionable. Decision making is grounded in evidence synthesis across thousands of agent interactions, not gut feeling or limited analysis. Competitive advantage accrues to those who design superior coordination architectures, protocols, and incentive systems. What the slide communicates: the higher order intelligence and strategic moat created by multi-agent collectives. Now let's zoom in on the agent native imperative. Industries with digital native workflows, software, finance, insurance, legal, media will be reshaped first. The new moat: coordination design the protocols, memory fabrics, and incentive structures that govern multi-agent societies. Companies that re-architect now will set the standards for the coming decade. Multi-agent companies are not a technology choice. They are an adaptive imperative in a world where speed of coordination defines success. The window to build agent-native architectures is open. The cost of delay is exponential. What the slide communicates: the urgent call to action architecting for multi-agent systems is the defining strategic move of this era.